Okay, it's that time. So let's go ahead and get rolling. So now we've done pretty much whatever we can with whole numbers, and we've started to talk a little bit about the symbols. So let's work a little bit more with those symbols. I know a lot of people get nervous when we start throwing X and other letters into the mix. But all that is it is well, we talked about it yesterday as being a label or a name. And what it stands for is just an unknown amount. So X itself is a number, or is a numeral, I should say, an amount, even though it serves as a name with an amount next to it. It's like 4X, remember, the 4 is the count that tells us how many, and X is the name, which tells us of what. So really what this number is, 4X, is it's really 4 times another amount, whatever that amount X is. We just don't know what it is at the moment, or we choose to leave it out. And that variable can be used in several different ways. It can be used to define, like I said, an unknown or a number that we are looking for. If I want to use proper English, I suppose a number for which we are looking, but this is math, so I don't care about grammar. Anyway, it would look something like this. X plus 7 equals 11. So it's an amount that we're trying to find. We can figure it out. It's just holding that place right now until we figure out what value it has to be. It has a specific value. We just have to figure out what that value is. Or it can serve as an unknown in a formula. Oh, for example, your pay equals your hours times your rate. So there we have P, H, and R. Those are all variables, all letters. They can take on any value according to the situation. Now, their values are related. Once we know the value of 2 of them, the third one is calculated. But yes, the number of hours you work in the week can be anything from 0 to however many hours you can fit in. Your rate is anything from minimum wage to whatever it wants to go up to. So they can take on any value. So they don't have a predetermined value. We're going to look at working with both of those a little bit today. The first step we're going to take is creating a formula like these from words. So the simplest description I'll give you is going to look something like this. A number increased by 4. If I were going to put that into symbols and numbers, what would that look like? X plus 4. Very good. Now, it doesn't necessarily have to be X. You could use Y, Z, N, A, B, whatever letter you wanted to put in there for that unknown number. But what this is saying is we have an unknown number, which we're using the X for. It's increased by, so we have something added to it, and 4. There are a lot of other phrases that could indicate X plus 4. We might have 4 more than a number. That would be X plus 4, or 4 plus X. It's the same thing. A number plus 4. Can anybody think of any others that would be X plus 4? I'll throw one in here. The sum of a number and 4. What's the word sum mean? It means addition. Technically, sum is the result of an addition problem. So it's the result of a number added to 4 is what that's saying. There are a lot of other phrases that could mean X plus 4. Those are just a couple. So what if we had 7 less than a number. Now this one's a little tricky because our minds want to latch onto it. Well, the 7 comes first in the words. We want to put the 7 first, but we can't do that here. What does that come out to be? X minus 7. 7 less than something means 7 is being taken away from or subtracted from something. So we're subtracting 7 from a number, which is X. Other phrases might be a number decreased by 7. 7 less than a number could be a number less 7 is another way of writing it. Can you think of any others? The difference, very good, of a number and 7. Just like sum is the result of an addition problem, difference is the result of a subtraction problem. And again, there are several ways several phrases that would all indicate X minus 7. Now with the X plus 4 up here, we said it didn't matter if it was X plus 4 or 4 plus X. Because when you add two numbers, the order doesn't matter. For subtraction, it does matter whether you get them right. So here it says the difference of a number and 7, that's X plus 7. If it said the difference of 7 and, or not X plus, X minus 7. If it was the difference of 7 and a number, that would be 7 minus X. So the order does matter when we're doing subtraction. Little variation, by the way. A number less 7, we said was X minus 7. A number is less than 7 is slightly different. That would be X less than 7. You can see it's very subtle difference. The word is in there is what changes that. Most of the time when we're asking for it, we're going to be asking for this. But be careful, that could get snuck in there. We have to have the less than or greater than symbol in there. I won't ask that on a test, by the way. If it's on a test, I'll be looking for something like this. I'll do this one easy. 5 times a number. 5 times X. Or we could just write it as 5X. Other phrases. A number multiplied by 5. Or 5 multiplied by a number, either way. When we're multiplication, we almost always put the number before the variable. It's 5 times X instead of X times 5. It's just a convention, a habit. Any others you can think of that come out to be 5X? The product of a number and 5. Again, the product is the result of a multiplication. And there are several others. There's just a couple. We could have a number split 3 ways. What's that going to be? Division. So X or N or whatever letter we want to use for that number divided by 3. Something to watch out for in my math lab, by the way. If my math lab gives you one of these phrases and asks you to put it in symbols, look right by the little box where you put your answer in. It'll either say it there or it'll say it right at the end of the problem. Use M to represent the unknown number or use P to represent the unknown number. You have to use the letter it specifies or it'll mark it wrong. Because you didn't see that? Yeah. It'll tell you what letter to use for that unknown number there. That's just because it can't recognize random letters. So other ways of writing, of course, We could write it as x divided by 3, or we could write it as x over 3. Either one of those is acceptable. Other phrases that mean x divided by 3, well, a number divided by 3 is 1. Anybody think of any others? Anybody know the name for the result of a... There you go. Quotient. The quotient of a number and 3. So now these simple, and there's others that indicate a number divided by 3 or x divided by 3. So these simple phrases are not so bad. They contain a single operation. Now I will argue that this here, and I mean these are pretty simple examples so far, but this skill right here of taking words and translating them, putting them into some sort of a formula of symbols and numbers is the single most difficult skill in math. Now what we've done here, like I said, are very straightforward and simple examples. But when we start getting into word problems where you have a situation, a 2 or 3 sentence situation sitting there, and you have to pick out the numbers and the formulas and put them together, that is a difficult process. That's something that you only get good at by doing it over and over again. And like I said before, starting to see the patterns. Oh, when the question's asking for something like this, it's going to look, the process for solving is going to be something like this. It's just experience is the biggest thing with it. There are a lot of subtleties to these word problems and these words. I'm going to have you try to do this one in your notes quick for me. Eight times a number increased by 5. Try that in your notes quick. I'll give you. What'd you get? 8x plus 5. Very good. If you had 5 plus 8x, that would be fine as well. So how about this one? Five more than the product of a number and 8. I'll give you a second to do that one in your notes. This one's tricky only because it's deceiving. You look at it and it looks like it should be different from the one we just did because of the way it's written out, but it's not. 5 more than something means we add 5. The product of a number and 8 is 8 times a number. So that one is also 8x plus 5. How many of you got that? Any questions as to why that has to be that? Come on. There we go. So the next one. Try that one in your notes quick, see what you come up with. This one appears to be the same, but it's not. The wording is very similar to this first one, except we have this in here, 8 times the sum. The sum is the result of an addition problem. So 8 times the sum is saying we 8 times the result of adding a number and 5. So it's saying we add the number and 5, x plus 5, first, and then we multiply it by 8. How do we indicate that? We have to put it in parentheses to say we do the x plus 5 first, then it is multiplied by 8. That one usually catches people. Any questions? Anybody get all 3 of them right? Okay. Usually I catch people with that 3rd one. Like I said, it's one of those things that the more you do, the better you're going to get at it. There's little cues and little words you learn to pick out. So now that we can, yeah? Then times 8 after the parentheses? No, because remember, order of operations says you multiply before you add. So you have to have, you could have the 8 after the parentheses would be fine, but you have to have the parentheses in there to force it to add first. Next step now, so let's look at how do we work with these symbols and numbers. Once we have them, how can we work with them? Well, one thing we can do is we can evaluate an expression. The command evaluate, remember I talked about keywords and cues? This is one of them. That keyword evaluate is telling us to do this next process. Evaluate means to give a value, which usually means you're going to replace letters or variables with numbers. So I might give you a formula that says your pay is equal to your hours times your wage. And you might be given the command evaluate for, bless you, hours equals 12 and wage equals 8. So that is saying is put those values in for those letters, for those variables, and calculate if you can. So H is 12. I replace the H with 12. W is 8. So I replace the W with 8. So this is saying my pay, which is equal to H times W, can be written as 12 times 8. I can combine those. I can calculate 12 times 8. It is 96. So P equals 96. Let's do a little bit different wording here. Evaluate when X equals 27, Y equals 12, and Z equals 3. In fact, I don't have to have the M equals in front. We're going to leave that off for now. Well, how would we evaluate this? Well, we replace each variable with its value. So 4x is going to become 4 times 27. 5y is going to become 5 times 12 over 2z becomes 2 times 3. Replace the z with the 3. Now this is simply an order of operations problem. Order of operations means you're going to do the top first. Up there, highest priority is multiplication. 4 times 27 is 108. I might take a couple shortcuts here. Plus 5 times 12 is 60. 108 plus 60 is 168. On bottom, 2 times 3 is 6. 168 divided by 6 is 28. What do you think? Good stuff? You want to try one yourself, don't you? So evaluate this when A equals 12, B equals 3, C equals 8, and D equals, oh, let's go with 3. All right, let's go with 2, sorry, for D. And F equals 2. So try that in your notes. See what you come up with. So our first step is to replace the numbers, the letters with the numbers. So 5A becomes 5 times 12 plus 3 parentheses 3. Okay, 3C becomes 3 times 8 minus D squared is going to be 2 squared. And then that's over. 2F will be 2 times 2. So now our next step is to do our order of operations. Again, we have a fraction bar, so I have to do everything on top first. I'm going to rewrite that over here. Now on top there, you okay? Okay. Well, if you need to go get a drink or something, just feel free. Okay, so on the top here, we do have another enclosing symbol. We've got this parentheses, so we got to start in there. We're going to do the exponent first. 2 squared is 4. Then we're going to do the 3 times 8, which is 24. (24 minus 4 is 20. We can now get rid of the parentheses because we're down to a single number. F remember putting the multiplication there. So 5 times 12 plus 3 times 20. Now we can multiply. 5 times 12 is 60. 3 times 20 is also 60. So 60 plus 60 is 120. Goes on the top. On bottom, all we have is 2 times 2, which is 4. So the bottom is 4. Now that we've done everything on top and everything on bottom, we can divide. 120 divided by 4 is 30. Perfect. Good job. Okay, those can get a little tricky. So that's evaluating a formula. If you're given the command to simplify, what that is telling you, number one, you most likely will not get a single number answer. Simplify is usually asking you to combine what you can. There are some things you cannot combine, though, and we'll look at those as we go through these rules. Just like we said yesterday, every number has a count and a name. And addition and subtraction, multiplication, division work depending on the rules for dealing with the count and the name. So if I have 4x plus 9x, remember when we add numbers, we combine the counts. So it's 4 plus 9, which is 13, and we keep the same name, which is x. So it becomes 13x. If I have 7y minus 2y, it's the same thing. When I subtract, I combine the counts. 7 minus 2 is 5, and I keep the name, y. Because of that, what do I get when I add 5x plus 2y? I get 5x plus 2y. They have different names. I cannot combine them with addition or subtraction. Now we talked about multiplication where we don't have to have the same name, and we're going to get to that in a couple minutes. Now just because there are different names or different variables in a problem does not mean we can't simplify at all. In this case we couldn't. There was nothing to change, nothing to combine. But we might have something like this. Here, there are different names, there's different variables, but there are some that can be combined. We can combine the things that do have the same name. You can actually think of this as being the same as having like 8 inches and 7 pounds and 3 more inches and 9 more pounds. What could we combine there? The 8 and the 3. 8 and 3 make 11, and we keep the same name of x. What else can we combine? 7y and 9y. 7 and 9 make 16, and we keep the same name of y. Now there's something missing in my answer right now. There has to be something that links these two things together, these two numbers together. Since this is a positive 16, yes, you put a plus in there. This symbol here links together the two digits of our number. So that plus is kind of like saying an and. If it's a positive number, that'll be a plus. If it's a negative number that follows it, it'll be a minus. That symbol goes with the number following it. It's linking that following number to the numbers before it. So this plus here is linking the 9y to all the digits that come before it. So let's look at something like this. Yes, those negatives are coming back to haunt us already. So I've got 12a and a minus 5a. Now I can look at this in two different ways. I can just say that's 12a subtract 5a, or I could look at it as that's 12a and a negative 5a. Either way, they combine to make 7. 12 minus 5 is 7. And we keep the same name of a. So yeah, whether we think of it as 12 minus 5 or 12 plus a negative 5, we get 7. It's the next part here that's the tricky part. I have negative 3b and negative 7b. It's easier if I think of those as negative 3 plus a negative 7. Think of my number line. There's 0, there's negative 3 and negative 7. That's going to be negative 10. We're going to combine the values. So now negative 10b, the negative becomes the minus that connects the two terms together. I could write it as 7a minus 10b like that, or an alternative way would be 7a and a negative 10b. That's acceptable as well. You can put parentheses around that if you wanted to. Yes? Okay, and that's a very good question because it can mean either. But you have to be consistent. I said when you're looking at this, you can think of this as either being 12 minus 5 or 12 plus a negative 5. Both of those give the same result. You can interpret it either way. Either one is going to give you 7a or 7. This, however, is a negative 3b. It's minus 3b, but it's a negative 3, and this is a negative 7. So it's easiest, or you can think of it as negative 3 minus 7, or you can think of it as a negative 3 plus a negative 7. It's easiest for me to think of it like this, is a negative 3 and or plus a negative 7. But you can interpret it either way as either a negative or minus. The key is how you link them together. And that is a little tricky because there are some times where it's easier to interpret it as a minus and easier to interpret as a negative. And again, as you get more familiar with working with the numbers, you gain more experience. It's easier to pick out when to interpret it either way. So I'm going to have you try this one in your notes. 5a plus 12b minus 9a minus 4b. Try to simplify that expression. So I'm going to do this first. I'm going to identify the ones that go together. This is positive 5a, and again, that can either be minus 9a or negative 9a, however you want to look at it. Those two go together. And we have, this is plus, so it is a positive 12b. And again, you can either think of that as minus 4b or a negative 4b. So let's combine the a's. I have 5 minus 9, or 5 plus a negative 9, however you want to look at it. Either way, it's positive 5 and negative 9 makes negative 4, and we keep the name of a. This is 12 negative 4, so either 12 minus 4 or 12 plus a negative 4. Either way, it's positive 12 minus 4 is positive, so we put a plus 8, and we keep the name of b. How many of you had negative 4a plus 8b? Good. We're getting better at it. Now, one of the reasons why I showed you the powers and the exponents is because I want to show you a little bit about our structure of numbers before we continue with these variables. We looked at our place values yesterday. This is the ones, tens, hundreds, and I'm abbreviating them numerically. 1,000s, 10,000s, 100,000s, and so on. Well, now that we have our powers, you can look at this. Anything to the power of 0 is 1, so we're going to put that as 10 to the 1. Or 10 to the 0, I should say, is 1. 10 to the 1 is 10. 10 squared, 10 to the power of 2 is 100. 10 to the third power is 1,000. 10 to the fourth power is 10,000. 10 to the fifth power is 100,000. This is what we call a decimal number system, or sometimes called base 10. The word decimal means base 10. The place values are powers or exponents with a base of 10, and then the power is going from 0 on up as you go to the left. If you get into computers or anything like that, you'll hear about binary or base 2 numbers. Well, those are numbers where the place values are defined as the powers of 2. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so on. And there are other number systems that are used in electronics that use different bases instead of 10 to define the place values. The reason I bring that up is that, let's say I have a number like 253. Its expanded form or full form is 200s and 5 tens and 3 ones. An alternative way of writing that is 2 times 10 to the second for hundreds, plus 5 times 10 to the 1 for the tens. Or I could just write it as 10. I don't need the 1 on there because the power of 1 doesn't do anything. And 3 times 10 to the 0 for ones. And most of the time we won't even write the 10 to the 0. We'll just write plus 3. The reason I point this all out, I know this here is review, but the reason I point that out is when we look at algebraic numbers, they take on exactly the same form. We can have 5x squared plus 3x plus 7. Notice now the place values, instead of being powers of 10, are powers of x. This is just a number written out in expanded form like that. So the way you work with it is exactly the same way you would work with 253. If I wanted to take, let's do my 5x squared plus 3x plus 7. Now I'm putting it in parentheses, not because I can do anything with it. Just like when we did the negatives, the integers, I put it in parentheses to separate it out from the rest of the problem. That's all I'm doing there is putting the parentheses around it. So that's one number. Plus this number, 3x squared plus 9x plus 2. To work with these algebraic numbers, it's exactly the same as working with whole numbers. I write them out, lining up the place values. The x squareds go with the x squareds, the x's with the x's, and the ones with the ones. And we are adding. Now we just add down each column just like we do with whole numbers. 7 plus 2 is 9, so that's a positive 9. 3x and 9x is 12x, so that's a positive 12x. One of the advantages of algebraic numbers, by the way, is you don't have to carry. You don't carry the 1 there, because it's not, the digits don't link like that. 5x squared plus 3x squared, 5 plus 3 is 8, so it's 8x squared. And that's the solution right there. Now, of course, one of the big differences between, well, one of the differences between algebraic numbers and whole numbers is algebraic numbers always have to be written out in expanded form. Another big difference is with our integers, either the whole number is positive, every digit is positive, or every digit is negative. Negative 372, that's a negative 300s, and a negative 7 10s, and a negative 2 1s. That negative makes every digit negative. For algebraic numbers, it's possible to have individual digits positive or negative. We could have 4x squared minus 7x plus 5. So you can see that only that middle digit's negative. The other two are positive. Because of that, it makes working with algebraic numbers a little bit more difficult because we have to worry about negatives. We might have 6x squared minus 3x plus 9 plus a negative 2x squared plus 7x minus 12. We're going to start out exactly the same way. We're going to line up our columns. So we write the first number out. Then we're going to line up the x squareds with the x squareds, the x's with the x's, and the 1's with the 1's. And we are still adding down our columns. What is 9 plus a negative 12? Well, 9 plus negative 12 is positive 9. Negative 12 goes past 0, so we know it's negative. And it's the difference between 12 and 9 is 3. They go opposite directions, so that's the difference between their values. Negative 3x plus 7x. So we've got negative 3 plus 7. They go opposite directions. We end up on the positive side. So it's going to be positive. And since they 4, perfect. Since they go opposite directions, it's the difference between the values. So the difference between 3 and 7 is 4. So it's a positive 4x. 6x squared plus negative 2 x squared, so positive 6, negative 2 ends up at a positive 4 x squared. You can see how that works just like whole numbers, only got to deal with the negatives. So if you try one in your notes. Yes, this whole thing is the solution. That is as simple as you can get it. I know a lot of people look at that and they feel like they should do more, that they need to be able to go further with it, but you can't. I want you to try this one in your notes quick. See what you come up with. So we set it up, lining up the columns. Negative 5 plus 2, negative 3. 7x plus a negative 9x, negative 2x. Positive 7, negative 9 goes past the 0 back to the negative side. And then 3x squared plus 2x squared, 5x squared. How many of you had that? Okay. Subtraction. We've already looked at subtraction with some simple ones. Let's look at something like this. Actually, you know what? One more example I want to do before I move on to subtraction. Sorry. If you run into something like this, what you'll notice here is what's basically happening is there's digits missing. This is 3x squared plus 8. There is no x digit there. But when we go to do operations with it, we need to put that in there. What do we put it in as? Well, there's 0 x's or no x's. Or we could just leave a blank spot here. But we do have to have that digit, the x place value, accounted for. Because now we're going to add 5x and negative 3 the negative 3 can only be combined with other ones, the 8 ones. 8 and negative 3 make positive 5. The x's can only be combined with other x's. That's why we had to have the 0x put in that first number. We had to account for that x place value. 0 plus 5 is 5x. Positive, so put plus in front of it. And then there is nothing to combine with the 3x squared. I show you that example because it's going to come up when we do subtraction. When we do subtraction of these algebraic numbers, it's just like what we did with addition. We line up the like place values. So I'm going to write the first number, 7x squared minus 5x plus 2. Now the 3x squared goes under the 7x squared. The positive 9x goes under the negative 5x. And the negative 4 goes under the 2. And now we have to remember that we are subtracting in each column. And this is where it gets tricky. This is 2 minus a negative 4. Now, because there's negatives involved, I'm going to change this to addition. 2 minus a negative 4 becomes 2 plus positive 4. We add the opposite. The opposite of negative 4 is a positive 4. So 2 plus 4 is 6. That's a positive 6. Looks funny, doesn't it? Whereas 2 minus a negative 4 is 2 plus 4. Now we have negative 5 minus 9. So again, I'm going to change that. Negative 5 plus a negative 9. So from 0, we've got negative 5 and negative 9 both going the same direction. The answer is negative 14, and we keep the name of x. 7x squared minus 3x squared. Well, that's just 7 minus 3 is 4x squared. What do you think? The subtraction is a little, you throw those negatives in there with the subtraction. I told you the integers would come back time and time again. Unfortunately. Try this one in your notes. See what you come up with. So we write it out again. Making sure we line everything up, and we are subtracting down each column. So this is a negative 5 minus 2. I would change that to negative 5 plus a negative 2, which is, careful, negative 5 and negative 2 goes to negative 7. Now this is a 7x minus a negative 3x. So 7 minus a negative 3 becomes 7 plus positive 3. We add the opposites. The opposite of negative 3 is positive 3. 7 plus 3 is 10. So this is 10x. It's a positive 10, so positive 10x. 3 minus 8, negative 5. 3 minus 8 is negative 5. X squared. Those are a little tough, aren't they? I'm going to show you something here just because it's the way the book does it. I don't necessarily like to do it this way because it's a shortcut. But one thing the book shows to do is this. You just drop the parentheses. So these parentheses, the first set of parentheses just go away. Before you can drop the second set of parentheses, though, you have to do something with this minus here. What you do with the minus is you change the sign of every digit inside the parentheses. So positive 8x squared becomes a negative 8x squared. Negative 3x becomes a positive 3x. And positive 2 becomes a negative 2. So you can see each one of these is the opposite of what we did up here because of the subtraction there, the minus. Now that's exactly what we did. We just did it one digit at a time as we subtracted each column. We did add the opposite. And now from here you can just combine the ones that are the same. 3x squared and negative 8x squared make negative 5x squared. 7x and 3x make a positive 10x. Negative 5 and negative 2 make a negative 7. Get the same result. So if that's easier for you, feel free to use it. It's just it's a shortcut, so it's not really doing things how it is they're really done. Any questions? I'm looking out there and I'm seeing full across almost everybody's forehead, so I'll try to keep it short and wrap it up here. So let's take a look at something like 6x times 4x. When we multiplied yesterday, we said we multiply the counts. So we're going to do 6 times 4, which is 24. But we also multiplied the names. X times x is x squared. Because of that, we said when we multiplied, we do not have to have the same name. Addition and subtraction can only combine things with the same name. Multiplication, not so. We could have 7x times 3y. And we're going to combine. 7 times 3 is 21. Then we also combine the names. X times y is just xy. So when we multiply, we can combine those names. We can combine things with different names. So I can have 8x squared times 5x to the 4th. What am I going to get? I combine the counts. What's 8 times 5? 40. Then I combine the names. What's x squared times x to the 4th? Remember, we add the powers. 2 plus 4 makes 6. X to the 6th. So here, 7y to the 4th times 4y. We combine the count. 7 times 4 is 28. Now the y to the 4th times y can be a little tricky. Remember, we don't write it here, but what power is really here? 1. It's y to the 1. So it's 4 plus 1 is 5. That's y to the 5th. Y to the 4th times y, or y to the 4th times y to the 1 is y to the 5th. How do we handle this? 3x to the 8th times 5y squared. Combine the counts. 3 times 5 is 15. Can we combine the 8 and the 2? No, they have to have the same bases, right? But we still can multiply them. X to the 8th times y squared is x to the 8th times y squared. Doesn't matter whether I call that 15x to the 8th y squared or 15y squared x to the 8th. Does it make a difference? Technically, no. Makes no difference. But believe it or not, there is grammar in math. And in math grammar, we try to put the variables alphabetically. So x comes before y, so it should... Technically, it's correct either way, but it's more proper to list it as 15x to the 8th y squared. How about this one? Well, I can multiply the 5 and the 8. I multiply the counts. 5 times 8 is 40. Now for the names, I can combine the powers that have the same base. So x squared and y to the 4th make x to the 6th. 2 plus 4 is 6. Y to the 5th times y to the 6th. 5 plus 1 is 6. I'm going to have you guys try one. Try that one in your notes quick. So we combine 7 times 5 is 35. X to the 4th. 3 plus 1 is 4. And y to the 7th. 2 plus 5 is 7. How many of you had 35, x to the 4th, y to the 7th? Any questions? So far, we've combined single-digit algebraic numbers with multiplication. What happens if there's one that's not single-digit? For example, let's say we have 3 times 21 for whole numbers. Well, if I were multiplying that out, I always put the number with the most digits on top. So I put the 21 on top times 3. And remember, when we multiply, you don't have to have the same name. So that means every digit of one number can combine with every digit of the other number. So you have 3 times 1 is 3, and then you do 3 times 2 is 6. With algebraic numbers, it works exactly the same. If I have 5 times 7x plus 2, I put the number with the most digits on top, 7x plus 2, times 5. We're multiplying here. 5 times 2 is 10, so it's a positive 10. 5 times 7x, 35x. And that's it. So I might have 3 times 4x minus 7. Same thing. I write the 4x minus 7 times 3. 3 times negative 7 is negative 21. Now when we're multiplying, we have to think of that as a negative 7 and not minus 7, because it's 3 times a negative 7. 3 times 4x, 12x. So it's 12x minus 21. Now some of you, or many of you, if you took algebra before, learned something called distributing. Distributing or distribution is just a shortcut for what we just did here. All that does is we multiply backwards, really, is what we do. We see that this 4x minus 7 is multiplied by the 3, and we do this. 3 times the 4x is 12x. 3 times the negative 7 is negative 21. Notice it's really the same process. We went front to back instead of back to front. We can do that because when we have algebraic numbers, we never have to carry or borrow, for that matter. It works out the same. It's just this distributing takes up less room on the paper. I want you to try that one in your notes. 5 times 8x minus 3. So I'll do 5 times negative 3 is a negative 15. 5 times 8x is 40x. Or the same here. 5 times 8x is 40x. 5 times negative 3 is a negative 15. Either way, 40x minus 15. How many of you had that? Okay, good. We're getting there. I can make it a little bit more complex. If you haven't learned by now, it always gets worse. I might be a little more proud of that than I should be. What's that? So, well, you know, as a math class, if you still have time for a social life, I'm not doing my job. So anyway, 3x squared plus, didn't have much of a life before, you know, that makes my job easier. So anyway, when we have these parentheses, one thing we should always check is to make sure we can't combine anything in the parentheses. Can I add 5x to the third and 8x? No, we can't. They're the same name, but there's different powers. So technically it's a different name. X to the third and x are different names, technically, because of the powers. Think about it as being like having a 5 and an 8, but this is thousands, and this is tens. We can't combine them because they have different place values. So same here. So we're going to multiply. Now I'm going to start distributing just to shorten things up a little bit. So I'm going to take the 3x squared times the 5x to the third. What's 3 times 5? 15. X squared times x to the third. X to the fifth. 2 plus 3 is 5. Now I'm going to do the 3x squared times 8x. What is 3 times 8? 24, positive or negative? Positive, so I'm going to put plus 24. X squared times x. X to the third, because this is x squared and x to the 1. 2 plus 1 is 3. That's not so bad, is it? Try that one in your notes. So again, I'm going to distribute to save some space. I can't combine anything in here because it's x to the fifth and x squared. So those are different names. So 5x to the third times 4x to the fifth. 5 times 4 is 20. X to the 8th. Good. 3 plus 5 is 8. Now I'm going to do 5x to the third times, remember that's a negative 2x squared. 5 times negative 2, negative 10. X to the third times x squared, x to the fifth. Very good. Any questions? The next step. What happens if we have two two-digit numbers? Think of if we had, 32 times 41. We did 1 times 2 is 2, 1 times 3 is 3, We left a blank space, then we went over, we did 4 times 2 is 8, and so on, right? Look familiar? Our long multiplication. With algebraic numbers, it works exactly the same way. The difference is they're written out in expanded form. So let's say we have 3x plus 7 times 5x minus 2. We can write it out. 3x plus 7, 5x minus 2. We have to remember to treat this as a negative 2. So this is a negative 2 times 7 is negative 14. Negative 2 times 3x is negative 6x. Now, just like with whole numbers, we've got to leave a blank spot here, or we could put a 0 in there if we wanted to, put in a plus 0. Now we have 5x times 7 is a positive 35x. So I put a plus in front of it. 5x times 3x, 15x squared. And now I can combine my negative 14 with 0 as a negative 14. Negative 6x and a positive 35. Well, negative 6 and positive 35 make a positive 29x. And my 15x squared. So what I just did here is long multiplication. And it's called long multiplication because it is the long way of doing it. But it is actually the full way, the correct way of doing it. There is a shortcut that many of you may have been taught if you had other algebra before. And that shortcut is called, come on, it's called FOIL. F stands for first. So that means you multiply the first digit of each number. 3x times 5x is 15x squared. Notice we did that down here. O stands for outside. So that means you're going to multiply the outside digits, the 3x and the negative 2. 3x times negative 2 makes negative 6x. Notice we had that here too. I stands for inside. You're going to multiply the inside 2 digits. That's the 7 and the 5x. 7 times 5x is a positive 35x. Again, we had that down there. And L stands for multiplying the last 2 digits. So that's the 7 times the negative 2 is negative 14. Right there. And now to finish this, you have to combine what you can, which is the negative 6 and the 35x, which is a positive 29x. Notice we get the same answer. It's just this makes more sense to me because that's how we multiply whole numbers. This is just a shortcut. If that works for you and you like it and you remember how to do it, feel free to use it. I'm not going to stop you. But if that you struggle with that and this makes more sense, please feel free to do it the long way. Did you guys figure out what you needed? Did you ever? Oh, the L stood for last, yeah. Last 2 digits. I'll do one more example of that, then I'll let you guys try one. So 4x minus 3 times 7x plus 5. I'm going to do it out the long way. 4x minus 3, 7x plus 5. I will multiply. Positive 5 times negative 3 is negative 15. Positive 5 times 4x. 5 times 4, 20, and it's just x. Now I'm going to leave a spot here. 7x times negative 3 is negative 21x. Notice it has to line up with the other x's. 7x times 4x. 7 times 4 is 28. X times x is x squared. And we can combine. We've got the negative 15, 20, and negative 21 making negative 1x. I don't have to put the 1 on it. I can just write negative x. And then the 28x squared. Questions? You guys ready to try one? Maybe not. Let's try it, and if we have to, we'll go over it and do another one. 3x plus 7 times 5x minus 4. Give that one a shot in your notes. So as we multiply here, we've got negative 4 times 7 is negative 28. Negative 4 times 3x, negative 12x. Then we move over 5x times 7, positive 35x. We make sure we put that under the other x. 5x times 3x, 15x squared. And now we can add down, and it's just a negative 28, negative 12x and positive 35x, positive 23, and we keep the same name of x. This is where it's confusing. You know, when we're multiplying up here, we have to combine the powers, but when we're adding down here, we're keeping the same name. So now that's just 15x squared there. How'd you do? Anybody lost? Anybody ready to cry? What's that?
I said I'll get it though.
Okay. This is a process that we will see over and over again a couple more times at least. It's not something that we have to know today. It's kind of the next, yeah. That'll help to have someone extra to go through it with as you do the homework, because there's a lot to take in 2.5 hours, unfortunately. So yes, if you need to, it's nice to have someone to go over the little pieces later on. But like I said, this is a process that we will go over again. And I don't think there's even maybe one of those problems in the homework today. I think we stop at doing the distributing up here. This stuff is where it stops today. But it can get into something where we combine like an order of operations. Like we might have 4 times 3x minus 7 plus 8 times 2x plus 3. Now we see parentheses. There should be 2 questions we always ask. First question is there anything we can do in the parentheses? So let's go left to right. Let's do this one first. Anything we can do in those parentheses? No. 3x minus 7 can't do anything with that. Second question is there anything that needs to be done to the parentheses? That parentheses is being multiplied by 4. So we would go ahead and do that. I'm going to do the shortcut, distributing. 4 times 3x is 12x. 4 times negative 7, negative 28. Next set of parentheses. Anything we can do inside that parentheses? No. Is there anything we can do to the parentheses? Yes, times 8. So 8 times 2x is 16x. Now there's no symbol here. That's a positive 16. So I'm going to put in plus. So there's something to connect them. 8 times 3, 24. Again, it's positive 24, so I'll put a plus in front. Am I done? No, I can combine 12x and 16x, make 28, and we keep the same name of x. Negative 28 and positive 24, so negative 4. Perfect. So we can combine operations with our algebraic numbers. I'm going to have you try one. Try that one in your notes. So we start with the first set of parentheses. Anything we can do inside that parentheses? No. To the parentheses? Yes, times 8. So 8 times 3x, 24x. 8 times 7, 56. So positive 56, or plus 56. The second set of parentheses. Anything to do inside the parentheses? No. To the parentheses? Yes, it's multiplied by not 2, but negative 2. Very good. Negative 2 times 5x, negative 10x. Negative 2 times negative 3, positive 6. Negative times negative is positive. So now 24x and 10x. Careful. Positive 24, negative 10. 14. Positive 14. 56 and 6. 62. So 14x plus 62. The one operation we haven't talked about yet, and we got 4 minutes, 3.5 minutes to do it. Looks like this. Just like multiplication, when we divide the counts. What's 8 divided by 4? 2. And then we also combine the names. X to the third divided by x, well, we think of that as x to the 1. When we divide, we subtract powers. So 3 minus 1 is 2. So it's x squared. So we might have 56 x to the 8th divided by 7 x to the 3rd. We start out dividing the counts, the numbers. 56 divided by 7 is 8. Then we divide the names. X to the 8th divided by x to the 3rd is x to the 5th. Good. We're subtracting the powers when we divide. 8 minus 3 is 5. Talk me through this one. 24 divided by 8 is 3. So we combine the counts. What's next? X to the 2nd. Good. X to the 5th divided by x to the 3rd. We subtract the powers when we divide. 5 minus 3 is 2. So x to the 2nd. And then y to the 1st, or just y? Because y to the 3rd divided by y squared, 3 minus 2 is 1. So it's y to the 1 or just y. If you had the 1 there, it's not wrong. What do you think? I'm thinking we reached our limit about 35 minutes ago. Okay. Remember, you still have time to finish homework 1 if you need to. Technically, that's due at noon today, but again, it'll cut you off, but you'll be able to go back into it and finish if you want to. New stuff. Quiz 1 is due tonight. I say midnight, but technically it's 11:59 p.m. And homework 2 will be due for Thursday. You get a day off tomorrow to catch up and absorb things a little bit, and we'll see you on Thursday. Remember, by the way, next week, Tuesday, is Unit 1 test already, so make sure you're...
Next Thursday?
Tuesday next week.
Oh, Tuesday.
Tuesday. So we have Thursday and Monday class, and then Tuesday is our test. I know it's summer. It comes up really fast. Technically, normally that should be at the end of the 3rd week, but that ends up being halfway through the 2nd week for summer.